movie critiques. This is Claire Mack, and this is People.
You have been listening to People, hosted by Claire Mack here on FM 91. People is in transition, and you, as the listener, will be a big part of this transition. Starting on Monday, November 16th, People will be a live call-in program, and you can talk to Claire's guests such as Matt.
Well, so I had one of the great surprises of my life on Friday after coming back to my office after class. On top of my desk was a copy of Hints for Referees that I had mentioned in class that we were searching high and low for. And so now we have it as a handout here. And it's not all that great, but it's not too bad. And it turned out that Jack Snoink, who's a student in this class, had received a copy of this from John Hirschberger, who graduated this year, and John probably received it from somebody else, and some other student, and so it's been passed down. So this is an nth generation copy for some in, and I don't even recognize the style of commas in this writing, so I'm not sure that it's mine, but it's close to what I wrote in the 60s, I think. And so it summarizes the main points that I said on Friday. Still, I want to belabor them by talking still some more about refereeing today and giving some more examples. Let's see, some other announcements, though. I guess first, here we are in November, and November 18th is one of the big deadlines that you should all remember. We would like you to turn in a rough draft, which is the closer it is to the final draft, the better, because you get better feedback then. But what you turn in on November 18th should be a a beta test or something, or a preliminary version of what you plan to do afterwards. But we can give you this feedback before it's too late. We're going to get some response back to you after that. It'll take us a little time to grade it, of course, but the final day of, I'm not sure exactly the day when. Did we ever tell you when the term papers are actually due in December? No? Well, it's sort of like whenever this class would normally have had its final exam, that would be the day. Now we have another guest lecturer coming in December, on December 7th. This is Rosalie Stemmer, who has taught copy editing at Stanford in the past and is teaching it at Berkeley. And I told her, and she's a copy editor for the Chronicle, and even though Gorbachev is scheduled to come for the summit meeting on December 7th, she's got somebody to take her place at the Chronicle that day, and she'll come here and give a talk. And I've asked her to give the best 50 minutes of her class at Berkeley on copy editing, and we'll all be in copy editing mode by that time, since the term papers will be due soon. So that's probably number 6 in the total of guest lecturers in the quarter then. Rosalie Stemmer. Stemmer as in I don't know, something has only one M anyway. You might say Stemmer if you were German. Another funny thing crossed my desk on Friday afternoon. I was telling you about people who mix the order of M and N when they, from alphabetical order. And so here's a formula that I think is rather remarkable. You see, emphasizing the commutative, or don't you think that's remarkable? Nobody's laughing. I mean, I thought this was hilarious. Okay. This is, something that I would have written with MN in the natural order in all cases, but somehow or other he doesn't get. What? Well, this is multiplication of integers. Yeah, right. Yeah, this is, but the amazing thing that he found, by the way, for those who are interested in mathematics, is that you take this product here. Alpha is the golden ratio, 1 plus root 5 over 2. And you form this product, and it's associative. There's no way it should really be associative. I mean, there's this rounding error, round to take the floor there, and then multiply these together, two approximate results, and then do that again on this sum. It's not distributive, but it's associative. It's incredible. But I thought it was a funny formula. I was going to spend an hour last night proving that it was associative, and 5 hours later I decided to give up, but I believe it. I proved that another operation was associative that I liked better. So I wrote to him about it. Well, now, refereeing. Herb mentioned the paper that I wrote under an assumed name in order to get, because I had the chance, since I knew he was the editor, I knew that he could send it out for refereeing without giving my name on the paper. Now, some journals actually do blind refereeing. They cover up the author's name, and I think one of the AMS journals does this, cover up the author's name when it goes to the referee, so that the referee isn't supposed to just say, oh yes, so-and-so really knows his stuff, and I'll just pass it without even looking at it, and somebody else is some unknown I never heard of. What right do they have to publish anything, and so on. Now, there is some influence. Sociologists have found that there is some influence on the names of papers when you're reviewing them. I mean, they did an experiment I read about some years ago, and I believe that it was reported correctly. Although you can't believe everything you read in the paper. That they took like 5th and 6th grade papers that were written in English, and they had them graded by two different groups. And in one case, they just changed the name on the paper. Somebody whose name was changed from Herbert to Sam or something like this, and they found that they were getting a definite a full grade difference. I mean, certain people with certain names would get a C instead of a B with the identical paper, and it was consistent, very strong statistical correlation. So people seem to be influenced by their preconception as to what a paper is going to be like just by the author's name. It's an amazing thing, but it seems to be true. Now, I chose in this case a name that was based. I mean, anybody who reads Agatha Christie would realize that UNON is a pen name from the what is it called, the and then there were none. But I made it Ursula, just in order to try to get extra discrimination. I mean, certainly a woman has no right to publish anything deep in computer science, right? Well, I don't know. Anyway, so we did this, and I got to explain some of the background for this, because see, this was dated July '81. Here's a letter I wrote in April '81. It says, "Dear Bruce, I was surprised to find that my paper was accepted with no referees' reports. Anyway, I reviewed it myself and found that it needed to be improved, and so I started having to get my own referees where I wrote to well, typically I also will send to people that I think are knowledgeable in the field. Anyway, because I think they might be interested in a preprint, and so I had to make. But anyway, I got no. So here I sent a paper, and I got a postcard back saying it will appear in such and such issue. Well, that's not good form. Here's the letter I got from a man in UCLA who I sent the revised version of my paper, and he reread it and he made more comments. So he gave me a referee report. In other words, even after I had sent the revised edition, I made more corrections on galley proofs. I had to go do this myself. Literate programming. I showed you that article about literate programming in the Computer Journal. So I got back. He says, "Thank you for enclosing your paper, Literate Programming. I shall be delighted to include this in the Computer Journal at the earliest opportunity." I got no referee report on that. But also, I sent that paper to Wirth and Dijkstra and Nauer, and got no answer from them either. They don't have time to read that kind of stuff. So that particular paper, I had no feedback on at all. Had to just take my chances. It could have been better if I had somebody looking over and saying, "Don, work harder." This was the report that I got on the paper that was submitted by Ursula, and well, it's generally. It's something that helped me to look at to see the detail. I just want to show you the idea. Then suggestions and corrections. So here I pointed out a gap in my exposition that I had just given letters L, W, D, G without any comment as to why those letters are appropriate, and suggest here to call it something like that. I'm not sure what D and G mean anyway, and then similarly here. So in other words, this was a good suggestion to improve the exposition. Here I have feedback from a motivated reader. What more can you want before you publish something? You see, find the questions that people are going to ask. Here are technical typographical error. I had a 5 instead of a 4. Subscript missing and a variable misnamed, and now here he had a change, and here it's wrong. I mean, I said no here. I mean, it is my own writing here. It turned out that he thought this should be this. He's wrong, but still, there was a reason why he thought it was wrong. So I had to add some other sentence, to clarify that this is sort of a sick, that this really is this way, even though you might think something else. So I had to, so that caused me, even though the referee is wrong, in fact, there's a few more places here, here it says, in fact, I made a comment to myself that this was a bug in my first draft. In other words, he's simplified. He's doing something which seems right, but turns out to be wrong when you look at it. It was kind of subtle, and so now I realized that I ought to add more explanation in the paper at that point. Okay, so when you get a referee report, also even when the referee is wrong, the moral is he was not the only person in the world who's going to read that and make the same wrong conclusion. In fact, he's the kind of person that you probably are hoping most to reach in your article. So you want to add a little redundancy so that the reader will understand that. Okay. What's this one now? Here's another one that comes from '81, the same year when I was having trouble finding referees. Well, here I got a good one because I went to a journal, Number Theory. It's a highly specialized journal, and again, I'm an outsider. I'm not ordinarily. That's not my work is number theory. I just happen to have solved the problem that the number theory is proposed, and so I wanted to submit it to the proper journal. But now here it says the main result is a simple formula, which the proof is not very complicated. It's not unlikely the result is already known. In fact, I mean, there's millions of number theorists in the world, but I haven't been able to spot it in the literature, nor has Henrik Lundstedt been able to find anyone able to answer the question among the people he has asked. Therefore, I'm submitting it in hopes that your referees will know the true story. Well, so here I am in '81, trying my best to encourage to get good referee reports, because I've been having these experiences where nobody's refereeing my work anymore. Now you might also say that I'm exploiting the system. I mean, here I am, I'm too busy to go to the library and look this up, what if everybody would do this and let the referees do all the work? I mean, this is kind of a lazy approach. Well, no, I don't think. I mean, here I made a serious check. I talked to leading people. I looked as I can, but the literature and such things is very vast, and the only way to really solve information retrieval problems on technical results being new is really to go to the people who are the world authorities on this stuff, and those people, that's part of their service to the world, is to be the world authority on that thing. I mean, you're going to be a world authority on something too, and people are going to want, going to come to you, and you're going to know this, and that's the only way really to do it. There's no perfect indexing system to find this material, and so it's a cooperative effort, and it takes place. I think it's one of the ways in which is one of the nice ways in which science advances. I mean, cooperation through correspondence, as well as through working in the same lab for a certain salary or something like this. This is something that we do as a joint enterprise, and it works as long as there aren't enough, a lot of dumb clucks spoiling it. And you can imagine all kinds of scenarios in which this kind of system would break down, but it does tend to work. And,
so what's your estimate, your subjective estimate of the probability that the result has to exist before you'll resort to that?
What do you mean? I'm sorry, the result has to exist?
So if you think that there's a 90% chance that this result doesn't exist, then you'll do this. But I'm saying
if I think that it's almost certainly well known, then I would probably, I'll give it a good shake to find out. I mean, I know how to use a library, and there's histories of number theory. Dixon's History of Number Theory, for example, 3 volumes that went through thousands and thousands of papers and gives them in capsule form, and so you can look there and find all kinds of stuff. But as you grow older, you learn where you might naturally find some results. And other ones, like I wrote a letter to Levesque about a number theory. See, if somebody wants to surprise me with something on my office desk after class today, there's a theorem that we had on an old exam. It was this: if the greatest integer, which we call the floor of mx1 plus mxn, is equal to the sum of the greatest integers, mx for all m. X1 through xn are real numbers, and this is supposed to hold for all n. So this is for all m, integers m. If and only if at most one of the x's is an integer, all but one x. Xk is an integer. Now, And we had this on a final exam once, and in this book I'm writing, Concrete Math, I want to give credit to where this came from. And when the TAs gave the answer to the final exam, they said they got this problem from the Math Monthly. And I looked through the Math Monthly problems. I spent about 10 hours so far looking through the previous issues starting in 1972, going back. I got back to about 1963. At all the problems in the Math Monthly and didn't see it. Now, Math Monthly has been published since 1890s, so I'm not going to, and I wrote this. I wrote to Scott Drysdale, who was the TA, and he said he doesn't remember, but he did remember that it was from the Monthly. He saw it somewhere. What? It's Math Magazine. Yeah. So that's interesting. Yeah. But so if anybody, so I wrote to number theorists, asked them if they knew where the result is. They said, "Hey, that's a neat result. I never saw it before. It sounds pretty interesting." So got that letter today, saying they don't know. So I can't haven't been able to retrieve that. Okay. So the main thing is though, you should give it, a reasonable shot, and not just be real sloppy about this and let everybody else do the work. And I put in a lot of time reviewing other people's papers, and this is my chance to get some of their time back. It's only fair. And as I say, it makes science advance better to do it this way. Now, so I got a letter back from the editor, and he said I've sent it to a referee and also read it himself. Have a few minor comments, and he gives me feedback right away, and then he says, but the question whether it's known will have to be answered by someone better acquainted with the literature, and so he sends to a referee. Now he gives me these comments here, and here he corrects typographical errors in the paper, and these are, I'm guilty of that. I should have proofread the paper better before I send it to him. Here's one thing, though. He says one could give a stronger result, and here he gives an error. He gives so he says, why not give a stronger result? I gave an error like 2 to the minus n, and he says there's this irrational number defined by this equation, which my argument will still prove a stronger result. And the point is that I knew that I could prove a stronger result, but I didn't think it was anywhere near best possible. So I thought that for the expository purpose, there was no point in giving the best error that I could get from my method, which I felt was sort of weak anyway. The main idea was to get some kind of an error term, but not the best possible, and unless I had a much sharper method that I was using. So, but it proves that he read the paper. I mean, in other words, but this is an example of what I think George Poya would call a facile generalization. There's 2 kinds of ways to generalize results. One is what he calls soft, and one is what he calls hard, or something like this. And there's the kind that you can generalize by just looking at the argument, changing nothing, but just seeing how what that same argument will support if you what axioms does it really depend on, and you define those axioms and so on. And anybody can go through that sort of like a machine and generalize the result. But then there's a what?
That's all.
It's that I think it's yeah. Well, let's see now. This is in the preface to problems and solutions in analysis, the one that Herb Wolf mentioned. It's a wonderful quote, actually. And there's a similar comment like that in his book on patterns of plausible inference, something like that. How to solve it. That's the shorter book. I don't think it's in there. Anyway, this is the facile generalization that has, but then there's and this is what the editor supplied there, which I did, but I didn't believe that it was worth it in this case to do it. Sometimes it is. Then there's the real generalization, where you find a pattern that is of significance, and then you give it a proper name and terminology, and then you develop a theory for it. Now those are much harder to come by, and that's real mathematics. I don't know how. Now I got the referee report back then from the editor, and it came June '82. So he apologized about how long it took, and then he quotes from the referee report. It's strictly related to some deep results of Erdős Turan, and later of these, here are the main references, and he gives the formulas that are related, and so on. But the results aren't the same. So we're talking about similar problems, but not identical. So in other words, he found this referee found some papers that I'm sure would be very difficult for me to retrieve in a million years. In these, here we go, 1958. This is one of thousands of math journals and so on. A title called "Remarks on the Theory of Diophantine Approximation." I mean, no clue in the title what's exactly in it. But here we found, through the referee's help, a relevant reference. Now, and then he said, then the referee says, he looked carefully, then he didn't find anything closer, but he suggests that I ask Erdős, or better yet, Sprinzuk, who was acquainted with the Russian literature, if you want to make absolutely sure. Do you want me to do this, And so I said yes. But he's, are you more interested in speedy publication or being sure of the existing literature? Well, it turned out I said, go ahead, ask Sprinzuk. And meanwhile, some Dutch mathematicians using my paper were able to generalize the result, sharpen the methods, and get a much stronger theorem, which got published before my paper did. But that's okay. I still wanted to know. My argument was simpler, and I got a weaker result. But it was, as it turned out, by using stronger methods, you could get a stronger result. But that's okay. Still nice to know simple methods once in a while. So finally, he says, I finally heard from Sprinzuk, who finds the results in your paper quite interesting and new, and recommends publication. So it's finally getting published. Here's the November '82, and so that did get published then. Okay, now here's another one, a recent referee report. This was July '85, and so wait a minute, is this in order here? Okay, well, yeah, I guess so. Yeah, so I don't show the letter, but anyway, I had previously worked with this editor, and I got a terrific referee report from him in a previous thing. So here I'm complimenting him, saying, "Boy, you found a terrific referee on this paper of mine." I revised it, and since the referee's comments led to considerable improvements in the exposition and results, you may want to run it by him or her again. The last section in particular has been completely rewritten. On the other hand, I did try to check these results carefully, so I won't mind if you decide to save time by forwarding it directly to the printer. The thing is, in this case, this is one of the examples I wanted to show you where the referee actually improved the theorem and remained anonymous, and just as part of the cooperative enterprise of journal publishing, says here's a theorem that ought to be published in this paper of Knuth, even though he's got this good result. Now, if he were real jealous of all of his own work, he would go and publish his own paper about this thing. But that's not typically the way it's done. And so here's the report, and in fact, I had two referee reports. But this one was by some master. I have no idea who it is, of course. Maybe if I studied the typewriter, I could work it out. Here it suggests if there's an easy proof to a remark I made, it should be given, because he tried to verify it, and it took a while, and I don't remember the details of that. But now here's what I'm talking about. It says, it seems to me that if we have so-and-so, this is a paper on coding theory, we can always construct a scheme that does it. And so he gives me a brand new construction which generalizes the special case that I had for h equals 3 or 4 or something like that. and his argument is very nicely worked out combinatorially here. So he gives me this nice way of sort of a geometric pattern that I hadn't had. I didn't realize this way of looking at the problem. He gives me this geometric pattern as sort of as a way of blocking lines that every way of going through here has to cross through one of these dots or something like that. He had a real nice argument there, and so I was really glad, of course, to get a referee report like that, because it allowed me to take my special case for h equals 3 or 4, or 8 or whatever it was, and show a general construction. And so then at the end of the article, I, of course, added acknowledgement for several penetrating observations that substantially improved this paper. I guess I should have been even more explicit. When the thing came out in print, the author was just thanking an honest referee for several penetrating that substantially improved this correspondence. And by the way, the referees at IEEE are terrific, but their copy editors aren't that good. But this was okay. I thought, technically speaking, this went in the correspondence part of the journal rather than the papers part of the journal. And somebody asked about that on Friday. That's why I brought this here. Somebody said, "What about letters section?" Well, these are refereed also. They're just shorter, and so they put them under correspondence. But it's a little bit funny too, because it's actually a one-to-one correspondence that I was talking about, and so I got to use correspondence with a double meaning here, which is very nice. But I told you a few weeks ago that this journal, IEEE Journal on Coding Theory, has a way of doesn't use apostrophes when they say zeros and ones. This was something we were in the midst of some other discussion, but wanted to so people used to when people used to talk about the 50s, they used to say apostrophe 50 apostrophe s. First apostrophe for leaving out the 19. The second apostrophe for making it a genitive, possessive, belonging to the for forming the plural of a symbol. The second apostrophe was to form a plural of a symbol to make 50s. Okay, so now the both apostrophes are left out in the 80s, and even in the 80s when we talk about the 50s, and except in the Palo Alto Weekly a few weeks ago, they talked about the apostrophe 60s. They left out the second apostrophe, but not the first. And more often, people leave out the first and not the second. But they're both going off now, typically. Still, when you're forming a plural of other things, like you dot the I's and cross the T's, and you have to talk about A's and B's in a formula or something like that. Still usually put the apostrophe in. And I said at the time that I didn't think the IEEE Transactions on Information Theory, which talks about coding all the time and has zeros and ones all over the place, I didn't think that they put apostrophes in when they gave a plural of zero. Well, what I hadn't remembered until I looked back at this paper, that they actually spell it out, zeros and ones. Z-E-R-O-E-S, and I believe that's wrong. I mean, their copy editor, just even though they work with it all the time, you're talking about a zero as a symbol, not as a number. And I believe the right rule is that you spell out a small number if it's used as a number, but not if it's used as a symbol. And I don't have the example of the page here, but on the galley proof. But there was but it came up where it just made the thing very ambiguous, because here's the word one in the sentence, and one is also a pronoun that is used in English to mean one does this or something like this, and so one something. So I couldn't. So I had to rewrite several sentences because of this well, I was referring to, change a 0 to a 1 or something like that. I mean, the sentence would have made perfectly good sense if it had shown as a symbol. But otherwise, it looked like a semicolon. So I had to substitute the word unity for 1. Now this is often done in mathematical writing. You say as x approaches unity or something like this, or the radius is unity, because they find out that if you say 1 in those contexts, it reads funny because the 1 has this multiple meanings in English. And if you can use the symbol 1, you're better off than having to say unity, which is a sort of a funny mathematical convention just to get around this rule. Well, enough about that, though. Okay, now let's see. Here's another comment in a paper that came out. Let's see. This one says title. This had an interesting comment from a referee. It was neat. The title is ambiguous without a hyphen. Optimal font caching. But hyphenation may not be appropriate. My favorite hyphenation problem, this is what I liked about it, appeared in a technical paper where the author wrote about common sense amplifiers. And I think he needed a common sense amplifier to write this correctly. As a common sense amplifier, no. With the present title, I was very interested in learning about optimal fonts and found no discussion about such animals. If the title were optimal font caching, it's not clear if there are a sufficient number of font cachers around to be interested in it, but in fact, there are. But in the event the ambiguity issue is present, the authors are free to find a suitable way to correct the problem. So we changed the title of the paper based on this to introduce another word, prepaging, which is actually this is transactions on programming languages and systems. So systems people know the word prepaging, and this is this is actually a keyword that we should have had in the title. Anyway, and so anyway, now this was otherwise a fairly lightweight referee report. They didn't dig into some of the problems in the paper that they could have, but look at this. It's thoroughly written. This is not. Now here's the other referee report we got. So I don't want to give the impression that you always get only one report. Depends on the journal you submit to as to how many referees they typically do. And when I was when I was editor, I would sometimes get only one report if I thought that one would be sufficient because of the subject matter or something like that, or if it was more controversial or a longer paper or something, get more or something. I don't know. But here is another report that I got, and here it had all kinds of references to what the referee thought were relevant references. And well, in my opinion, again, these references were not relevant, and I looked them over again to double check my opinion on this, and so I finally decided probably not to cite most of these because they were talking about a different problem, and still it's an honest mistake that you have to realize other readers are going to make. Now the paper itself, I brought with me because I wanted to show you it starts to answer the question of how to describe a complicated algorithm with sort of what was I going to say? How can you get across the feeling of a complicated algorithm by giving traces of the way it runs or something like that? I talked about animation of algorithms the other day. It takes a lot of work to do that, but can you get the effect across in a journal article rather than somebody actually playing with or going ahead and implementing it? Well, this is one of the more extensive examples that I did of trying to understand to present this, and so let me give you a little background on this what this paper is. Now, I was working on typesetting, and we have a manuscript that's come off that has been processed by tech, And now we have to take it onto a machine that has a small memory for storing its fonts. So we have a big computer, and we have a small typesetting machine. The typesetting machine can store about 100 characters in its memory at any one time. And so the big machine is supposed to cache these things. In other words, it's supposed to decide which 100 characters are in the small machine, and periodically it says, forget character number 32, replace it by the following character. And the question is to try to do this in the optimum way. So that now we have the whole manuscript in front of us, and so we have time at the end of every line to change a few characters while the machine is moving its motors around. And so we have time on line 38 of a page to load 5 characters of boldface that we're going to need on line 50. So this is called pre-paging in the sense of operating systems, which would say that if you had time and you knew that a user was in a few minutes was going to want a certain page from the disk to be present in memory, you could bring it in now, maybe, if the disk was idle, instead of demand paging, which is waiting until somebody demanded the page and then stop and work on some other job and then resume when you got it. So we have the whole text of the manuscript in our we know the future, unlike the operating system people who doesn't know maybe what the user is going to do unless the user has some is using a sequential file or something. We might want to know that he's going to bring in the next record. In this case, we know the future. We know what characters are going to be coming up on line 60, even when we're doing line 30. And so that's what this paper is about, trying to say when you have time to bring in a limited number of things, which are the best ones to bring in, and can you prove that they're optimum in some sense. Now how do you explain the effectiveness of such an algorithm? That is, and so we go through a long presentation and then we give algorithms here. As I mentioned, I've been using a Pascal-like style with a sort of a web indication, also with presenting algorithms in these publications now. But how do you? So we presented the algorithm, we proved it correct, and we showed some certain kinds of optimality. But now we got empirical tests. We wanted to test it in practice, and so I discussed the models that we used and the samples that we did. But it really has to be done on a realistic job. You can't on something like this. No random model is appropriate. Things are too complicated. You want to really discuss it on something that's typical of real life. And so what I did was I gave so I constructed a test file consisting of 5 pages, which do a lot of different kinds of typesetting. And here was page 1, and here was page 2. This was based on excerpts of volume 2 of the Art of Computer Programming. Actually, this sample comes from the test pages that I made when I was designing tech. I went through volume 2, and on page 1 I copied a lot of it, and then I got to stuff that I already knew how to do. So then I went to page 50 or something like this, where there was an algorithm. And every time something new came along, a different aspect of typesetting, then I would say, how should I write this in tech? And I'm designing tech as I'm doing this. I mean, this turnout was also my test. This particular page was actually the test case that I used as a sitting down over one night and 2 nights thinking out what the tech language should be. I would try to say, what kind of a source language would I like to generate these pages? And then I had the source language, and I said, okay, now let me implement it. And then actually, after I implemented it, a year later, I used this page also for testing it. And then we tested it on, so I had this file around sort of as an example of all kinds of different typographic conventions. So here you get to the bottom of page 1, and then all of a sudden at the top of page 2, you got 9-point caps coming in, even though you've been working in 10-point size type, and so you have to bring in all these caps before you get to the end of page 1 and so on. And there's the tables and rules. All these different things are coming in here. Made a fairly good example of a test program, and it continues on here. So it has math formulas and quite a variety of different things can happen. What is this? 3333. This subsection doesn't exist. Finally, okay. Well, anyway, this was the idea. So now, how do we describe how well the method works? Well, so now I describe. Now we want to set the thing up by simulating different speeds of the typesetter and different amount of internal memory inside the typesetter. So we can find out. So we can sort of shut off the heuristics here. We can say that the typesetter doesn't have any kind of preload characters at all. How many page faults do you get then, or how many character faults do you get then? Or what if you have infinite memory and you know all the various different things could happen. And so my table here, which is described, there are different conditions on how much look ahead you have time to do. Like L infinity meant infinite look ahead. L0 means no look ahead, no pre-paging, and so then we count how many times when we did this figure, how many times we had a character fault and had to stop and wait.
What's fault?
Fault means that the character that it needs for this line is not present inside the memory, so you have to go and you have to go to the end of the line and then come back and do it and load some more characters and do it again. That's what it is actually. But so it was hard to explain the effectiveness of the algorithm. But my best solution to this was to try to present it, by some numerical table that would then discuss it afterwards. But then I put an asterisk in here saying anomalous values that are surprisingly low. For some reason, I would have expected, like here, if we increase the memory, we should not also increase the number of faults. Somehow having more room should be better. But it's people who work with these parallel these algorithms know that sometimes you can that you get this monotonicity goes the other way. So you have more processors and it takes longer to run a job because you make a bad mistake in the beginning or something like this. And in this case we have a situation where the characters have variable size, and so you've got to not only you don't only have 100 characters, but you have to fit them into slots, and they might not work nicely if they come in a certain order, things like this. Very complicated. But anyway, but the main thing I did in order to describe the algorithm was to typeset this diagram. And this diagram was typeset and it shows the actual behavior of the algorithm. There were two main ideas in the look-ahead procedure, and I don't want to dwell on it, but essentially the farther you are here, the more lines you are ahead. So your memory is loaded up until I think. This line coming down here is consuming characters, and this line below it is loading characters. And when those lines come together, you get a fault because you haven't been able to preload them fast enough for the consumer. And so you try to get ahead as much as you can by taking, like at the beginning of a page, the motors are moving to part of the film, and so you've got time to load enough characters to get all the to get you started, and then you try to, and so you have a little time to load more in, and so this diagram was then based on computer outputs the details of how the algorithm performed, and then I could typeset a diagram by typesetting little lines, and also then I would showing where you are in that sample. Like you say exercises, or when you got to exercises, that's that's where the horizontal line is here when you get to this part which says exercises. See, so you can, so that's the idea of this diagram, and I guess the moral of it is that now with the computer typesetting tools that we have, we can make accurate figures that would be unthinkable. You know, it would have cost a fortune to get such a figure done, and you would never have the patience to get the data and do it right before. So now we could hook up the algorithm to the typesetting system and actually give some kind of a pictorial output of the algorithm. And there's many more examples of this can be thought of. So then, giving some kind of a snapshot picture, some kind of a way of visualizing the algorithm is, each algorithm has its own specific problems, but you look at it, enough examples, you get a feeling. I'll show you on Wednesday an example of exactly how not to do it. It was the first paper that I published in the Communications of the ACM. It's my second publication. My first publication was in Mad Magazine, but that was different. I didn't draw the figures for that. But this one is an example of the wrong way to do it. And then I'll show a couple of more examples of this idea of trying to give a description of an algorithm by what do you call it, play-by-play or snapshots. And if anybody else has better ideas, they're always welcome. This is a tough problem.
We want to see your first publication.
Excuse me? You want to see my first publication? Okay, I'll bring the first publication. All right. Okay.